Welcome to an Achieving Science video. Within this video we are going to look at parallel circuits. For this then, we first of all need to begin by drawing out a circuit diagram. Within this circuit diagram we need a cell, we need some components, so we're going to have a filament bulb. We're going to measure the current, so we need to use ammeters which are placed in series. And as this is a parallel circuit, we need to have a second branch which has a bulb and a further two ammeters. So what are the ammeter readings going to do? They're going to tell you the current, the number of electrons that are passing past or through it. So here we have 10 amps on the first branch, going to 5 amps, going to 5 amps, and then going to 10 amps. Well, this essentially shows you that current is being shared in a parallel circuit. So there's 10 amps coming out, but they are going to split between the first bulb and the second bulb, both receiving 5 amps each. Is this then true about potential difference? Well, first of all, you need to remember how potential difference is measured. Potential difference is measured using a voltmeter across a component, which measures the energy going in and measures the energy going out of each component. It uses a voltmeter. So let's put these voltmeters in place. Now let's see what these readings are going to read and show. Well, if we have 12 volts across the cell, we find out there is 12 volts across the first bulb and 12 volts across the second bulb. This indicates that potential difference is equal along each branch. It is the same. Now if we remember these two principles, let's apply it and let's work out the missing readings in a circuit. So again, let's have a circuit being drawn for us, where again it's a very similar circuit, but you'll notice that in the first branch we are only going to draw one bulb, as where in the second branch we are going to draw two bulbs. Now in the question, it's going to ask you what the missing ammeter readings are. It's going to provide you with two readings. The first reading shows you that 12 amps, and the second reading shows you 4 amps. Now we already know, therefore, that current is shared in a parallel circuit. So if 4 amps go along the second branch, therefore 8 amps must go along the first branch. It must equal 12. 8 plus 4 equals 12. Therefore we can now fill in the other branches. 4 amps along the bottom, and they must meet together again to form 12 amps again. Now what about the potential difference readings? Again, we first of all need to put in the voltmeters, as this is the means by which we're going to read the voltage, the potential difference. The readings that are provided to you therefore show you that the cell is providing 12 volts, and across one of the bulbs at the bottom we have 6 volts. Now the potential difference along each branch should be the same. Therefore, across the first bulb, the first branch, there should also be 12 volts, because it doesn't have to be shared with any other component. But in the bottom branch there are 2 bulbs, and therefore this would also need to be split. Therefore 6 plus 6 equals 12. Now resistance depends upon the current flowing through the component, as the potential difference is the same. The bigger the resistance, the smaller the current.